Hi all, in this one I'm going to show you a trick for finding a seemingly hard limit. So let's begin with this simple bit of information. So imagine that I give you a triangle that looks like this one right here. I'm going to build up a triangle. We have a side this way, we have a side this way, and then we have a side that way. And let's label the sides. For example, this is x, this is a, let me zoom in here, and then this is here x squared plus a squared. And based on this, we can get some limits, but here's one of them as an example. Imagine, let me turn up the grid, that here's the limit. Limit as x approaches positive infinity of, say, x divided by all the pieces added together. So in other words, it's saying what fraction is x of the whole perimeter. So I'm going to have here a plus x squared plus a squared. Now you might look at this and you might conclude, well, that looks like a pretty hard limit. How do I find that value? Well, one thing that you can do to avoid some algebra is, I know this is equal to 1/2, and it's true that I'm at the level where I could do this mathematically relatively easily. But I also think about things this way. I'm going to take a more kind of graphical approach so you can see how this limit actually works out. Let me put my grid back on. I need that so I can keep track of things. So first of all, to say that the limit as x approaches infinity is the value of whatever this is, x is going to infinity. That means x is going to be a very, very big value, and the a that you see pretty much is treated like a constant. Its value doesn't change. So that tells us that we can do things like this. Take a look. Imagine I'm looking at the triangle from far away. This is kind of like just using our imagination more than anything else. So if I'm looking at that triangle from very far away and x has gotten to be a very, very big number, for example, then the horizontal leg would be tiny, and this leg would be huge over this way, see? And then the hypotenuse would go from over here to over here. It would look like that. So in this context, you see that the vertical leg of the triangle, this is pretty small. Let me just make a note here. Small. The horizontal leg, as you can see, when I scroll all the way across, is huge. It goes all the way to here. So I'm just going to write this word in here, huge. And then the same thing happens with the hypotenuse, as you see there, that the huge, it's also huge relative to the vertical leg, which is small. And then here's the question. What this limit says is the following. What fraction is x of the whole perimeter? So if this is the case, then the whole perimeter, if you think about it very carefully, is really just contained in two pieces at this point. Here's one of them. This leg is one part of it. It's much, much bigger than the vertical one. And the other piece, as you can see, is the hypotenuse, which again is much, much bigger than the vertical leg. Because that is so, the value of the limit is 1/2, because what this says in simple English is what fraction is x of the whole perimeter. In other words, when x is a huge number, the vertical leg over here basically plays no more role. And all the perimeter is contained in the hypotenuse and the horizontal leg. So the horizontal leg, which is the value of x, has to be equal to 1/2 of the whole perimeter. That's it. This is how you can use your imagination to just go beyond manipulating symbols and really get at the essence of things. Just for fun though, because it's kind of interesting, let's find the value of the limit algebraically, confirm that it's actually equal to 1/2. So if I do that, take a look. I'm going to proceed as follows. First of all, because x is a huge number in the limit, a and a squared become basically irrelevant. They're super tiny compared to x. So for example, if x is a billion, trillion, million, then even if a is a million, it's essentially irrelevant. So for that limit, I'm going to say the following, that this is the same as limit x approaches infinity of x divided by x plus the square root of x squared. I'm just dropping the a's because they're irrelevant when x is a huge number compared to x. Then it's going to give me the limit as x approaches here infinity, and then the square root of x squared is just x, so this becomes x over x plus x, which then in the limit basically you get the limit as x approaches infinity of x over 2x, and as you can imagine, right, this cancels with that, and as I said, this is equal to 1/2. We have 1 over 2. Thank you so much for watching. I hope this has shown you perhaps a new way to think. Again, I personally think that to do math well, just use your imagination and think way, way beyond the box, so to speak. Or the triangle in this case. Thank you. Please leave a like. I'll see you in another video.